Hey, hi guys. Welcome to the 12th PyData meetup. So before we start, we just like to go over the PyData code of conduct. So PyData reminds us all to be kind to others, do not insult or put down others, behave professionally. Remember that the harassment and sexist, racist, or exclusionary jokes and languages are not appropriate for PyData. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriate. PyData is dedicated to providing a harassment-free experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of participants in any form. So thanks for helping make this a welcoming and friendly community for all. So today we're excited to have Nathan Stevens, who's a senior manager for developer relations at NVIDIA. And he will be talking about what makes our packages useful and why our users love them. So Nathan, when you're ready, you can start.
Thanks, Chris. Appreciate the intro. So I'm Nathan Stevens. I work with Torian at NVIDIA. I recently joined, and Torian's really helped me out with a lot of things, and it's been a good start to a good working relationship. In the course of that, he invited me to speak to this group. Now, my background is in R. I used to work for a company called RStudio. And I normally speak to our users, and I have a lot of experience doing that. I have less experience speaking to, people who've never used R. And my understanding is on this call, most of the people on this call have not used R, or if they have, it's to a very limited extent. So I'm going to give this talk assuming that there's no R use knowledge. So if you've never heard anything about R, that's exactly what I want to, what I'm looking to do here is to introduce R, but not so much from a programming perspective. I'm going to give a talk that I've been wanting to give for a really long time, but I can't give to R users because they don't care. so in R, if I give this talk to an R user, all our users already understand what makes our packages useful and why they love the packages. They already know that. So this is my opportunity to explain to other people from an outside, like why people on the inside of the community really like this thing. I hope that I'm successful, but we'll see. Torian, you said that you've only used R once. We'll see if this actually ups that metric at all. We'll see. So let me share my screen. We'll get started. Okay, now this is the intimate group. So if you want to stop me and ask questions, please don't hesitate to do so. I have a number of slides here, probably 20 minutes, and then we'll jump and do some demos for another 20 minutes or so. If you want to break me at any time, feel free to ask any questions. Okay, can I just get a quick thumbs up? You can see my screen okay?
Yeah.
Okay, great. I see the thumbs up, Chris. Thanks. Okay. So I want to make one point of clarification here. So my background is in R, but it's also has a real strong tie to using R in the enterprise, right? So R for business, generating revenue, right? Like, growing, using data, practicing data in industry and multiple verticals, and that's the background of this talk. So I'm not going to be talking so much about R from an abstract view or from like a academic view or from like learning perspective. I'm actually going to be talking about what it's like to use R in the enterprise. And that's going to come up frequently in this talk. So a brief history of R in the enterprise. So in 2000, R is released, at least stable enough to actually be used in industry. Many years pass, and a company comes out called Revolution Analytics. I don't know if they're the first, but they're the first that I know of that actually starts offering software and services to enterprises for the R programming language. A few years pass, and R Studio releases this IDE. Now, when you hear about R, oftentimes it's synonymous with R Studio because the R Studio IDE is used by 99.9% of the R community, and so those get used interchangeably, but they're not the same thing. R Studio is a company, right? And so this company releases the IDE, and a year later they release Shiny. They also start building a suite of software tools to use in the enterprise. I joined R Studio a few years later. 2015, Microsoft actually acquires Revolution Analytics, which becomes really important because a lot of companies that previously were unwilling to use R in the enterprise suddenly become okay with it because they're going to pull the bits, the packages, and the programming language from Microsoft, well, I should say through Microsoft instead of from the community sites. So that actually opens up this whole new opportunity to adopt R in the enterprise. And then that same year, the R Consortium is founded. That's a big one because a number of companies get together and say, we're going to fund projects that will ensure the sustainability of R in the world, but self-interestedly in the enterprise, right? So there's a recognition that tools are going to start layering on top of the R programming language in 2015 that will be ongoing. And in 2020, R Studio releases binaries for Linux. And we're going to be talking about why that's significant in this talk. But basically, that allows administrators to start using R more freely and more successfully in the cloud and in containers. Okay, so we'll talk about that here in a minute. Okay, so what makes R packages useful in the enterprise? Let's talk about where the R users get their packages. So the primary source for R packages is CRAN, right? And CRAN has 19,000, 20,000 packages today. It's grown exponentially over time. It's kind of monolithic. Most R users get their packages from CRAN. There's another source called Bioconductor. That's a more niche use of bio-related packages. And then there's a whole bunch of packages on GitHub that haven't been promoted to CRAN yet. But most users get their packages from GitHub. There's other ways to deliver those packages. So R Studio has a public package manager. I'm going to be showing that here in a second. Microsoft also has a time machine where you can pull packages from that as well. And then there are private meta repositories that you can install behind your firewall, like R Studio Package Manager and Minicran if you're in an air-gapped environment. And those will pull packages. Almost all of these packages are coming from CRAN for the most part. Some through GitHub, some through Bioconductor, but that's where you get them. Okay, so when you run R on a Linux server, historically, only package binaries were built for Windows and Mac. Packages for Linux had to be compiled from source, and that created a few problems, right? So some of the R packages take a really long time to compile from source. For example, the tidyverse can take over 30 minutes to compile from source, which is really problematic if you're like spinning up containers, especially dynamically. R packages require system dependencies, and for the most part, data scientists don't have permissions to install those system dependencies, so that's kind of a nightmare too. And these were always problems with Linux, but as as time went on, these became very challenging problems, real barriers for enterprise adoption of R. So the solution was to offer R package binaries. RStudio did that. They compiled them. They did it in 2020. They compiled it against a variety of Linux distributions. So let me, and they have a package, they have a public package manager that's hosted on Amazon services that anyone can pull. There are terms of use for it, but it doesn't require authentication. And any R instance that's connected to the internet can pull binaries from this system. So I'm dwelling on this a little bit, but there's a reason. I'm going to talk about that a little bit more here. Let me toggle over to, we have to remember how to get out of here. There we go. Package manager. Okay, so this is the public package manager. And if you're new to R and you're just using RStudio on your desktop, you're probably fine just pulling from Crayon, doing the default with Windows. If you're running on Linux on the cloud, you almost always want to pull from this because it's so much faster than the alternative. So if you come here to the packages, you can see this is Crayon. You have all your packages here. You've got the synchronization here, and then you've got the setup. So how you get started is you can pick the latest, or you can freeze a specific date, like on the 14th, and you can pull your packages from source or binary. You can change this to whatever distribution you want. So if you're running whatever, most people run CentOS or Red Hat in the enterprise, but I tend to run Ubuntu, works a little bit better for me. This is the URL for the package manager. So you copy this, and then you go into the IDE and you put that package reference right into the IDE. And now, instead of compiling packages from source, trying to find the dependent and hitting a lot of hard edges on the dependencies, these things will tend to install lightning quick with no issues. And if you do have dependencies, sometimes there are dependencies, like if you want to run Java, right? If you have a package that runs Java, you need to install Java. They've actually listed out all of the dependencies right here that you can run against your enterprise system to install. So the idea here is that the package manager basically makes it extremely easy to adopt R in the cloud and on containers and use in production workflows and to use in handoff situations where you have an R asset, you have to hand it off to somebody else that doesn't know R. So that's the barrier that this erodes and allows to open up. So it's not, so in the process of building all of this, they had to standardize on R versions across the different distributions. RStudio did. So one nice side effect of doing all this work was that they released R binaries for Linux as well. So again, keep in mind, I'm talking about the enterprise here, right? Because I'm coming from the enterprise perspective. Like if you're running the enterprise, you're probably in the cloud, you're probably running one of these supported platforms below. And historically speaking, installing R was very difficult. R looked like this. It was like, took forever. Admins didn't know about it. It wasn't easy to maintain on side-by-side instances. R users couldn't do it themselves. This was a nightmare. So all those problems have gone away now. And it's not very long ago, just 2 years ago, like all these problems kind of went away. So it's nice to have those gates open, and it's nice to be able to use R in the server. And I'm going to show you R in the server here in a few minutes. Okay, one quick comment, air-gapped environments. Again, many large organizations, oftentimes financial organizations, have their servers behind the firewall. Makes using R packages a nightmare because you can't connect to Crayon. You can't even get the source packages, let alone the binaries, right? So these organizations tend to have these really strict regulatory environments. They have difficulty, using any of this open source software, and they have restrictions on what pieces of open source software they're going to use. They can't rely on other things like Artifactory and Anaconda Enterprise because they do fine for Python, but not so much for R. So the solution there is you can actually run RStudio. You can run all this stuff behind the firewall as well, right? So you can snapshot all this information, bring it over, run it behind the firewall. So again, this takes us to why people, love R, right? People love R because they love the R packages. So when you talk to an R user and you say, like, what do you like about R? They will invariably say, oh, I love, ggplot2, or I love Shiny, or I love, the tidyverse, or, dplyr, or something like that. They don't say like something about the programming language itself typically, right? They're usually talking about the packages, and it's because there's a package for everything that you want to do. I oftentimes, co-opt that old marketing slogan from Apple, there's an app for that, if you want to do something, there's an app for that. Well, in R, if you want to do something, there's a package for it. And part of that is because where the packages come from. The packages, so let's talk about that. So the packages come from the community, and the community tends to be like researchers, scientists, students, people in universities largely, and they write a lot of the packages. And that means if there's a new statistical method that's available, like it oftentimes shows up in R really early stages. I was using, cutting edge statistical techniques back in the early 2000s, way before they were available on any other system. Times have changed a little bit. I mean, I think data, analytics has grown a lot, and Python certainly has, amazing amount of methods. But the methods in R are actually quite good. There's usually things that you can do in there. I'll show you the task views in a second. So, but it's not just for academics, right? There's statisticians, mathematicians, and in industry, business analysts, and all these new people, Excel users even go over to R. There's been significant investments made on making R more accessible and easy to learn and welcoming, right? And that's not just from the programming perspective, that's also the community. There's been efforts to make the communities a lot smaller than like a Python community, right? And there's a very good, welcoming vibe it's very inclusive. It's a very inclusive community. Let me put it that way. There's very warm, very inclusive, very eager to learn. And if you go to like a use R or an RStudio, conf, you'll see that there's just so many people there that are just brand new, wanting to, get involved with the language, or what's being done with the language. So what's it used for? What are people doing with this? Well, domain experts, it's often been said, I stole this line, domain experts can quickly and easily interpret, interact, and visualize data. It also allows scientists to document their work so it can be reproducible. And reproducibility becomes a big theme of scientific computing and the work that people are doing in R. So here's a simple diagram from Hadley Wickham. He's kind of the, he's the author of the tidyverse. In this diagram, we talk about importing and accessing the data, right? Then understanding the data and communicating insights about the data. So there's kind of this notion of these three different branches here where you're accessing, understanding, communicating. And Hadley goes through great detail in his books and his documentation about how this works in R. And you can do all of that so that other people can reproduce your work and yeah. Aspect of the R community is excellent documentation. There's just an expectation that the documentation will be good. Packages will install easily, documentation will be good. And a lot of packages have their own websites devoted to them, and they're involved websites. There's a lot to them, right? Beyond that, there's community sites that allow you to get the information you need. But by and large, the idea of good documentation is kind of like part of the culture of R. In fact, one person, this was a quote from someone I heard recently say, that, the single thing that makes R stand out from other languages and programming and programs is the superb documentation of the tidyverse package. And yeah, it's hard to understate. It's actually quite good. It's really quite good. So how's it being used in the enterprise? So how are all these people using the enterprise, right? Since my background is in research, I'm not going to spend much time talking about that. I'm going to talk about the enterprise. That's what I know about. The way I look at the enterprise is, these kind of three buckets, right? There's like data, science, and operations. So the data side, you've got all of your ETL, your databases, your data sources, your snowflakes, your redshifts, your Teradata, Oracle, right, and all the Informaticas and all the tooling and Alteryx and everything that's around the data. Operations over here is all about like the ML ops, right? The model ops and machine learning ops and DevOps, IT ops, all the systems that make an enterprise function, right? Like that are actually operationalized, have people looking at them, oversight, SLAs, uptimes, status alerts, security threats, compliance, regulations, redundancy, all of these things, right? This is all the operational side of the organization. And then you have this science area, the science bucket, right? That's kind of like in between the two that everybody knows about, but, executives don't always totally understand clearly, right? They understand the data and the operations, but they're like, okay, how does this science thing work? Now, it used to be that science was done on the laptop, and those were the resources. Now data science platforms have gotten a lot larger in the last few years, right? And so you do find R in data science platforms today, like you can get it inside of SageMaker, for example, right? Amazon SageMaker has a path to get our studio in it. Azure ML has, some things that it's working on as well. So it is available in some of the larger scale, data science platforms. Our studio sells a data science platform. It's in a variety of areas, but that's that data science laboratory where experiments are happening and business is functioning. That's where R tends to live, right, in this science corner. And I just will distinguish that compared to like Python, which is typically considered a general purpose language, which would span all three of these buckets, right? You would say I use Python for data ops and ML ops and ETL, and I can do the whole span. R tends to be in this experimentation zone, right? And that means that has certain implications for it, because that means that R tends to be used for a lot of things that other scientific, languages are used for, which is, learning and insights and understanding of data. Okay, so let's talk about installing the R packages. Unlike most programming languages, R packages are installed in the R session. It's easy for programmers to learn, it's convenient, and it encourages users to explore packages outside their standard library. Now off to, we're going to do a demo here. So we're going to wrap up the slides. I'm going to do a few more slides before I cut over to the IDE. The first one is the Crayon task views. These are not well known, so I always like to point these out. Let me pull them up here. If I do Crayon and I go, geez, where'd the task views go, guy? Could you Crayon task? These are the Crayon task views, and these aren't official. These are curated by community contributors. But if you want to come into, but I work at NVIDIA, so if I want to look at high performance computing, I can click this task view, and I can see that come here and I can see things about Hadoop, resource managers, right? GPUs, right? So this is how you use R with GPUs. These are all packages that you can, learn about. And there's a short description about these. And then it lists them all down here. So these Crayon task views are really, really handy. I'm going to highlight four distinct packages in my demos. One is Shiny. Shiny is a package that allows our users to build web applications entirely inside of the R programming language. It doesn't require any R, HTML, CSS, or JavaScript. And our user, and more importantly, actually, what this does is this allows an R user to build an application and deliver that to somebody that doesn't know R. So Shiny ends up becoming a big boost for like using R in the enterprise, because it means that other enterprise users can access, R. Tidyverse, I've alluded to this before. This is an opinionated collection of packages that all work together to do this, insights and understanding. And it's led by Hadley Wickham, but there's a whole team at our studio that is helping build out these packages. These are all free and open source, and they get a lot of contribution from the community as well. Our Markdown, researchers like to publish and author, documentations, whatever, books, reports, presentations. And Markdown allows you to do all of that. So we're going to show this. This is kind of cool, actually. I come from a publishing background back in my ancient days. And so I really like this. This resonates with me. And then Reticulate, which is an interface into Python. So we'll talk about that too. All right. That's the slides. Hope you're still with me. We're going to go over and actually start playing with the software now. Thank you for being patient. The slides are done. So, okay, so this is our Studio server. It's the open source version. It runs in the browser. There is also a desktop version of this as well. So if you want to run it on Mac or Windows, there's versions of this that you can run as a desktop app. I like the server. It gives me access to more firepower, and I'm used to the tools. And figure if I'm going to move something into like an operationalized environment, it's going to have to be Linux anyway. So here we are in Linux, and this is a simple R script here. I'm going to go ahead and let's do this. This is the R prompt down here. So if I want to do something in R prompt, it's like the Python prompt, right? 1 + 1 is 2, right? 1 through 5, 1 through 5. I can plot, data sets like Iris, come out over here, right? Close that out. What I'm going to do here is I'm going to load up the dplyr package. I'm going to load up ggplot2 package. This allows me to connect to a database. In this case, it's a SQL Server database. And this will pull data from the, and then I forgot, the database, shows things over here. I connected to the Aeron time database under the DBO's schema. And I'm going to hit the flights data, which is right here. I can see the flights. I can even pull up a sample of that. This is what the flights data look like. I'm going to connect to that flights data over here. If I want to take a look at it, I can see it down here in the console. And these pipes allow me to pipe from one command to the next command. These become really handy to chain your arguments. So what I'm going to do here is I'm going to filter, I'm going to group by, and I'm going to summarize the data. And that's all going to happen on the database. And then when I'm done with that, I'm going to collect that data back into memory, into the memory on my local computer. This SQL Server is running in the cloud somewhere, right? And then when I'm done with that, I'm going to go ahead and plot it using this ggplot command. This ggplot command is going to plot hour versus delay. It's going to break up the lines by origin, and it's going to be a line plot. So let's go ahead and there we go. So that's just a real simple example of what an R user would do in industry, right? Query a database, do some SQL manipulation, right? So one thing that's being glossed over here is all of this work translates from the R code into SQL code. So it actually writes the SQL for you in a dialect that SQL Server would know. Uses a package called dbplyr to do the proper translation. And then it submits that code off to the database. And then it runs it back. The plot commands tend to be really powerful. People like ggplot2 a lot. It's one of the most popular packages in all of R. I think it's hilarious. It's called ggplot2. I always tease Hadley that, where's the ggplot3? When are we getting ggplot3, Hadley? So, which the answer to that's never. There was another package called ggviz, if you're familiar with that. That was supposed to be ggplot3. All right, so this is a simple example of how you would use R with data and visualization. There's let me show you Shiny. So if you come up here and do a new file and do Shiny web app, give it a name, my Shiny. Create this. Okay. So this is a Shiny web app. Pretty straightforward. Not too many lines of code. Let me just run this and then you can see what this actually looks like. All right, so this is the Shiny web app. When I move the slider, it changes the number of bins in the histogram. So what's happening here is it's taking the 19, it's throwing it back to the R code, it's running a new histogram plot, and then throwing it back into the front end, right? So there's an R in the back end, and then all the JavaScript and HTML on the front end. That's all being done reactively. And that's why you get these commands called reactives right here. This render plot, well, this doesn't say reactive, this says render plot. The render plot is a reactive, but this is the input here. Input bins is what's being controlled. And this is the histogram that's, outputting the visual. And our users really like this, right? Because this is actually pretty easy to learn. It's pretty easy to read and understand. And it's powerful. It's actually Shiny gives you the ability to start off really easily and then go really deep. And when you fail nicely, right? They call it the pit of success, right? If you fail, you still end up getting someplace decent. So it makes you, makes you feel successful and want to learn more about the software. Now, this is pretty basic Shiny app. Let me show you a little bit more of like what we would actually use Shiny for. Come back here to. Slightly more interesting version of Shiny application. This is, a portfolio, and you can, you have some inputs here. You can have different starting dates, right? Windows, and you've got some tabs down here. You can analyze the data, right? And what's kind of cool about this is like the code for this is really easy, right? Like this thing is 200 lines of code. It's pretty easy to read. You can get the code right inside the app if you'd like. So people, so let me show you another one. We'll come back to this in a minute here. Customer tracker. Gonna run this app. This is a customer report that uses Shiny. And you can, select different inputs, year to date, whatever. And what's cool about this is like you can like do things here where you have like a download button. So I've like customized this chart, right? And I have this download button, and when I open up the Excel, see, I get the chart back in here with the data that I want. And all of the data are back here if I need that for a pivot table, right? So you can do these nice BI type of applications with Shiny. Shiny opens up this opportunity to like do business intelligence. Becomes very easy to quickly, get the information in the hands of the people that need it. And again, that's one reason I'm talking about the enterprise aspect of it, right? Like, why do people like are in the enterprise, and why they love the packages? Because it lets them do things very easily and powerfully that they would really struggle with in other tools. I'm not going to name those other tools. All right, so because I'm biased, I actually like R. So let's see. So like once you have that, like what do you do with these things, right? What do you do with these Shiny applications? Because these are all running basically on my desktop. Well, if we come back here to this application, I can also publish these applications, right? And there's a couple of free services. This is a test service of what's called Shiny RStudio Connect. There's another free service called Shiny Apps.io. That's those are both open, and you can explore them at your own leisure. But the point is, like, the ability to share these Shiny applications actually becomes quite easy. Push of a button. So I'm going to go ahead and not replace it. I'll call it my Shiny 2. So I say I'm going to like bundle up this application. I'm going to like keep track of all of the dependencies. So I need to know all the packages that I need. So I'm going to create a manifest. I'm going to ship it over to the server. This happened automatically. I didn't touch anything, right? It just automatically opens up this web page. I've left my desktop now, and I'm actually on the open web on this, server called beta.rstudio connect. And I've landed that manifest and my code on this script, on this service, and that service has taken the manifest and rebuilt the environment and has run the code and reproduced my Shiny app here. And so you can do this in a free environment. You can do this behind your firewall if you want, but this allows you to kind of, it allows you to have other people access, your Shiny app. And what's really powerful about that is that people that don't know anything about R now can have access to the power of R. In this case, they're drawing histograms, which isn't too exciting. But in that other case of the Sortino ratio for the financial, there's statistical models that are running behind that in R code, right, that people can access and take advantage of. All right.
Do you mind sharing the link to that so we can play with it?
To the server, or to which part?
The web page that you just had up, the Shiny app.
Yeah, so this was what I want to do here is I can go to this and hold on, I have to specific anyone, no login required. I'm going to save that. Grab this link. I go into the chat. There. Now, if you click that link, you should have access to this application. Anyone in the world should have access to that. There's another, if you want to play around with this yourself, probably want to go to Shiny Apps.io, shinyapps.io. And this is a great place to publish your applications, because they have it's designed to scale out a little bit better, because it's a freemium offering. There's a free tier and then a premium tier. Okay. So that's Shiny in a nutshell. Let me talk to you about publishing with our Markdown. So if I come up here to File, and I go to our Markdown, I'll go ahead and choose Untitled HTML. This is worth, this is worth a discussion. So it opens up in our Markdown document into notebook mode. Now our Markdown, you know, it's R for Markdown, right? And it allows you to put your content, your code, and your output to the code and your prose in the same document, like a Jupyter notebook would, right? What's slightly different here is that these are in plain text. So this is always plain text. And it will also, what else is different, it will also render in a variety of outputs. I'll show you that here in a sec. Here's a code chunk. If I want to run it, I run that. I can run this. I can run this. And then if I want to knit this, I can knit this into HTML, right? So I'm going to do HTML output. I want to knit this into PDF. I can make it a PDF document. And if I want to knit this into Word, I can download the Word document and open it up into Word. Show you what this would look like more in an enterprise setting. Let's go ahead and knit this. This will give you a report that you can email out. This is a notebook. You can see all the code if you want to, or you can hide all the code. Like I said before, there's a link to Excel, so you can download Excel here if you want, open up that data, and you've got some tabs. And again, this is going to be really, really quite easy to run and to understand. And these are going to be plain text. Let me show you what you can also do these in PowerPoint, which is kind of fun. It's fun if you're into PowerPoint. Oh, this is PDF. This is a PDF. Okay, so here's PDF. It's got column formats, right? It's got, they put a lot of work into the research side. You got like footnotes in here, right? You got citations. Yeah, and people in academic publishing love this, right? Again, it goes back to that reproducible nature of things. Okay, let's do, I wanted to do a PowerPoint one. Let's open up the tracker again. So PowerPoint presentation, we'll go ahead and knit this. Great. Yeah, so this programmatically can output, the visual and the table in PowerPoint format and the columns. This application didn't turn out proper, but that's fine. All right. So lots of different types of outputs there. You can do presentations as well. And those become really useful for, getting your information out there. Again, if you're like wanting to, quickly assess your data, explain it, and help other people like build on top of it, I think the R programming language does quite well with that workflow. All right, but the thing is that most people don't use R, right? The R community is actually quite large. It's actually not, I don't know what's the right word. It's a lot larger than people think it is. Let's just put it that way. And it's growing, which is good. The problem is it's not nearly, it's nowhere nearly as large as like a Python community, not even close. And as I mentioned before, it doesn't play in that. It's not a general purpose programming language. It's a scientific, language. So it doesn't tend to have as the same number of use cases or as much variety in use cases. So because of that, it behooves people that use R to know Python as well. Python is kind of unavoidable, right? So what do you do when you're an R user and you have to use Python? Well, there's a package out there called Reticulate, and Reticulate is an interface into Python. I keep talking about all these websites I haven't been showing you, but they're all here. Reticulate is here. Okay. And Shiny is here. And our Markdown is here. Right? Yeah, all places to go get more information. So if I come back to show you the basic functionality in here. So what you have is a chunk to load reticulate, and then to pick up the configuration for your Python installation. And then you can actually run Python code inside of these code chunks. So this is a Python code chunk, and I'm importing pandas, and I'm reading, flights data, and I'm doing a simple operation on it. And then I can use that, so that pandas frame is in memory, and I can actually use that pandas frame. I can call that and use that for R operations. So here I call ggplot. This is an R code chunk. I'm going to call ggplot2, and pyflights tells me to look at my Python environment and pull the flights object out of it. So I'm going to run this, and there's a ggplot2 from Python. So this becomes useful in a world where maybe you already have pre-existing Python scripts, or you have some Python, ETL, and you can drop that into your R Markdown notebook and still use all your R tools on top of it. Okay, and then here, if I go, I can actually read data into R. I'm going to go the other way around this time. I'm going to read the data in, do the same operations in R, and then I'm going to use a Python script to call it from R. So the R dot says, take a look at my R environment, pull the flights, and go ahead and run it. Oh, that was already in there. Let's do it again. Okay. So you can go either way. You can operate either way on this. So that's one of the things that's nice about the RStudio IDE, is that it does give you access to Python. And some of these things can get very sophisticated. We had this app that was basically a Shiny app, but it was running Python models under the hood, right? So it's a Python fueled Shiny application. Other things that the RStudio IDE can do is it can actually run Python code in the console in the REPL. I failed to point out that, see, I'm running a Python REPL here. That's what the three arrows are, greater than signs. So if I just come in here and I just want to run some Python code, I'm good to go, right? We're looking at the console here, right? So just running it through the console. I can source the script. If I'd like to source the script, that'll work too. And then when I do some, tab completion, if I do NP array, right? I get some simple tab completion in there. So you can definitely do it, right? Now, the question is, do you want to do it? And the answer to that is it depends. I think if you're an R user that wants to use Python and is comfortable inside the IDE, the RStudio IDE, and is already using it for a lot of R work, then I think that makes perfect sense. If you're a Python person looking to do Python code, would I pull up the RStudio IDE? I don't see that in practice. I don't see Python users picking up the RStudio IDE to do Python. The RStudio IDE is intrinsically linked to the R session, and it's very opinionated about all things R. So it's just not a place where you're going to get in my opinion, it's not a place where you're going to get the greatest Python experience. But it certainly allows you to do this interoperability between R and Python. All right, so just a few other little things I wanted to show here. If I come back to the stock portfolio, save anything. We have these Plumber APIs. So you can actually run APIs in R. It's kind of a funny little thing. You can do, so I can come in here and try it out. This is running Swagger interface. But if I do like, yeah, so it says like Google stock ticker, right? You can execute Google, you can see the call, and this is the information that's being applied. This is useful when you're trying to chain a lot of different things together. You can turn them into APIs, but that functionality is there. Let me talk about just briefly about the remote jobs, which I think which is pretty cool. If I run this script, you'll see that this is running one model at a time. So if any of you guys are running, this is running a LMER model, and my console's blocked. I can't do anything, right? Like it's stuck. So I don't know, a couple of years ago, what they did is they built in this jobs tab where you can say, I'm going to go ahead and run this job as a local job, and I'm not going to copy the results back. I'm just going to run that job here. Now it's running. You can see that it's running, and my console is free. I'm totally free. And this is oftentimes used for things like installing new packages. Let's see what happens if I do install.packages abind. Let's do here. No, it just installed it right there. Sometimes if you're installing a lot of packages, it'll like offload it to the jobs tab, and that'll free things up so you can keep working while you're installing packages, which is really nice. But you can also use the jobs to split up all the work as well, right? So if I want to run a local job here, watch this. If I do jobs, start a local job, start here, this is gonna bring up 3 jobs. Oh, and they all failed. I wonder why they failed. What happened? Dplyr, end. I wonder what happened. End. This was just working before I started this. Huh. Let's see an end.
So I think you have ends
There's
in
ends.
line 16 and line 20 is end.
And that's good eyes, Torian. Good eyes. All right. Yeah, so let's do end here. Let's save this. Start. Jobs, or are we not running the jobs?
Okay, I made it worse. Never mind.
Yeah, now it's not working at all. So no, because ends was right here, right? Oh, end went to ends. Yeah, I don't know. This was running, this was working, trust me, but that you can still see how it split up the job into 3 and you farm it out. This is locally, but there's another piece of technology called the launcher that you have to purchase. But if you purchase the launcher, you can actually like farm it out to a Kubernetes cluster, right? So you can like shoot out a whole bunch of jobs. The launcher lets you do all sorts of things. Lets you run on Slurm. So if you're doing Slurm, you can like run a whole bunch of stuff on Slurm as well. And that's one way to scale things out, but you have to pay for that. So, okay. I think that's probably a good place to stop. I can keep talking about R because I know a lot of stuff about R, but let me just pause here. It's been an hour. So Chris, I'll turn it back to you.
Okay, thanks very much. So now we open the floor for questions.
Chris, that's very kind. I didn't get a chance to say thank you, and it was an honor to be here.